Good afternoon, everybody. This is Eric LaChapa from La Posta Band of Mission Indians. I'm the executive director of the La Posta tribe. Thank you for joining us today. I have with me Ron and my EPA team and Mono, myself. We're going to do a little bit of outreach, knowing that with the COVID situation now, we can't have our Earth Day and stuff like that. So this is how we're going to be doing a few short videos to do some outreach for you folks. So bear with me. This is our first time trying this, so we'll get this started, and I hope you enjoy it. Thank you. The first question is, we're talking about the water cycle. So what the first question is, what is the water cycle? The water cycle is known as hydraulic cycle, which is a continuous circulation of water on, above, or below the surface of the earth in forms of solid, liquid, and gas. Why is this important? Because water cycle regulates the temperature, changes the weather, creates rain, and helps convert rock to soil and circulates important minerals. In this slide, we'll talk about the main process of the water cycle. Let's look at each of these processes. It starts with evaporation, where water turns into vapor. As water turns into water vapor, it rises up to the atmosphere, and the atmosphere becomes cooler. So the vapor turns into water droplets, again, and forms clouds. This process is called condensation. Apart from evaporation, sublimation is also contributed to water vapors in the air. Sublimation is a process where ice directly converts into water vapors without intermediate step. As opposed to sublimation, there's also what we call deposition, where water vapor converts directly into ice. Water also evaporates from the land surface, transpires from plants, and this process is called evapotranspiration. When the clouds are formed and become too heavy, it pours down as precipitation. The precipitation then leads to runoff, where water flows from high to low, and there are two types of runoff: surface runoff and groundwater runoff, which I'll explain later. Also, another process is called infiltration, where some of the rainwater is absorbed by the surface and moved to the ground. There's another similar but different step called percolation, where the water goes deeper into the groundwater. Next slide. This is to reiterate what we just said: the evaporation, the sun heats the earth's ocean, rivers, and lakes, therefore water rises and vapor in the air. Evapotranspiration, water evaporates from land surface and transpires from plants. Condensation, as we talked about before, as the vapor rises into the air, it cools off and turns into liquid again. When enough water vapor condenses, a visible cloud forms. Precipitation, water falls back from the earth, from clouds in different forms, such as rain, sleet, or snow. Transportation, water moves through the atmosphere, usually between oceans and land masses. Sublimation, snow, ice convert directly into water vapor with no intermediate liquid phase. Deposition, water vapor converts directly into ice as opposed to sublimation. And surface runoff, precipitation runs into rivers, lakes, and streams. Water is eventually transported into the oceans. Groundwater runoff, some of the precipitation that is absorbed by the ground to become groundwater. The water may return to the surface in springs, eventually return into the oceans. Infiltration and percolation. Infiltration is the movement of water from the surface to the ground. Percolation is the movement of water going deeper into the groundwater. Plant uptake, water is taken from the groundwater flow and soil and moisture. Again, these key concepts I just explained here, I'll explain. Sorry. The next thing I'll talk about is global water distribution. I apologize for that. As you can see in this graph, this bar chart, 96.5% of the Earth's water is in the oceans. Of the remainder, 68.7% is in glaciers and ice caps, 30.1% in groundwater, and 1.2% in lakes, rivers, and wetlands. Very little water is stored in the atmosphere. There are some concepts here as well as different types of water. Saline water is water that contains high concentration of dissolved salts. Fresh water is water that contains low concentration of salts. Groundwater is water found underground to fill the spaces between the sediments and the cracks in the rocks. And surface water is the water that collects on the surface of the ground, such as streams, rivers, lakes, and wetlands. I also provide you some information about aquifers as well. What is an aquifer? It's a body of permeable rock, sand, sediment, or soil that is saturated with groundwater. There are two types of aquifers. One is called unconfined aquifer that is near the ground surface and is able to rise and fall. The other one is called confined aquifer that is below the land surface and is saturated with water. You can see the differences in the graph. Water can add into the aquifer, form precipitation, and you can also discharge the water from the wells. And this is called recharge and discharge. However, if you pump too much water and there's little water coming in, it can lower the water table, causing a cone depression, as you can see in the slide. Next thing is talk about is wetlands. Wetlands is an ecosystem that is permanently or seasonally flooded by water. There are four main types of wetlands, which are marsh, swamp, bog, and fen. Wetlands is very important. It's sometimes called the lung of the earth. Here's why. Improve water quality by removing nitrogen, phosphorus, and pesticides from agricultural runoff. Provide habitat for fish, shellfish, and wildlife dependent on wetlands for survival. Offer recreational opportunities such as sightseeing, hiking, and fishing. Store and slowly release water during storms, which reduces the risk of floods and erosion. Are highly productive and biologically diverse compared to rainforests and coral reefs. Help provide clean water supplies in some regions. That's it for today. I hope you learned something from my talk. Thank you for listening and have a good day. We'll be doing more of these short presentations in the future. Thank you. Sure.